Hi, this is the second part of 6.2 on combining random variables. So this information is on page 369 to 378, so I suggest that you read that. If x and y are any two random variables, so we have basically two separate probability distributions. We're calling one x and one y. And we want to combine them together and find the mean of x plus y. Then we can just get that mean by adding the two means separately. So we add mu sub x plus mu sub y. If we were subtracting them and we want to find the mean of the difference of x and y, then we would subtract the two original means, mu sub x minus mu sub y. If x and y are two independent random variables, they have to be independent in order to do this, then we can find the variance, so this means the variance because it's standard deviation squared, of the sum or difference of the two variables x and y by adding the two separate variances together. So the variance of x plus the variance of y. And then we could just take the square root of that to get the standard deviation. We always add, even if you're finding the difference between the two random variables x and y, to find the new variance, you always add the two separate variances. So we're going to go ahead and try this. This is the Check Your Understanding on page 378. You can try it on your own and then we can go through it. So let's read it. A large auto dealership keeps track of sales and lease agreements made during each hour of the day. Let X be the number of cars sold and Y is the number of cars leased during the first hour of business on a randomly selected Friday. Based on previous records, the probability distributions of X and Y are as follows. So we have the number of cars sold, either 0, 1, 2, or 3, and the probability that that number of cars are sold. And it gives us the mean of that probability distribution and the standard deviation. And then we have the same thing for the cars leased. They were calling that Y. And either 0 cars leased, 1 or 2 cars leased, and then the probability of each of those outcomes. And it gives us the mean and the standard deviation of Y. It says define D to be the difference between the two probability distributions x and y. If we subtract x and y, assume that x and y are independent. So first we want to find and interpret the mean of D, which is the difference between x and y, the difference between these two probability distributions. We want to find the standard deviation of D. And then the dealership's manager receives a $500 bonus for each car sold and a $300 bonus for each car leased. Find the mean and standard deviation of the difference in the manager's bonus for cars sold and leased. Go ahead and pause if you want to just go ahead and try starting this. See if you can do it, and then press play and you can see the solution. Okay, let's go ahead and go through this. So the first one, we want to find the mean of D, which is the difference in x and y. So to do that, I have it up here, then we can just subtract the mean of x and the mean of y. So it gives us those values right here, 1.1 and 0.7. If we subtract those, we get 0.4. It also says to interpret that. So we're just going to interpret it in context what it means if we are finding the difference between these probability distributions. On a randomly selected Friday, because it's saying that that's when these values are from. It says if you randomly select a value on a Friday. So on a randomly selected Friday, there are 0.4 cars, less cars leased than sold during the first hour of the day on average. Because when we subtract, basically on average, there's a difference of 0.4 between the two. Okay, now we're going to do number 2, compute the standard deviation. So to do the standard deviation, you have to add the variances. So you want to, this is our formula, we want to do the variance of the difference between the two. Means we're actually going to add, even though it's a difference, you always add for standard deviation, but we're adding the variances. So you take the variance of x and you add the variance of y. Variance is just standard deviation squared. So we take the standard deviation for x and square it. That comes from here. And we take the standard deviation of y, 0.64, and square that. So if we add those together, we get the variance of D, which is the difference between the two. And then we want to take the square root so we can get the standard deviation. So the square root of 1.299 is about 1.14. And number 3, it's saying the dealership receives a $500 bonus for each car sold. So that means if they sold 0 cars, they get nothing. But if they sold 1 car, then they get $500 for that car. If they sold 2 cars, then 2 times 500, they'll get $1,000. So they get $500 for each car sold and a $300 bonus for each car leased. We want to find the mean and standard deviation of the difference in the manager's bonus for each car sold and leased. So we're finding, I'm going to call that mu sub b for bonus. We want to take the difference in the number of cars sold and leased, but we're going to multiply those by, for cars sold, 500, because they're getting $500 for each car sold, and then they're getting $300 for each car leased. So I'm multiplying the mean of the cars leased by 300, and then now we want to take the difference between those two. It's saying find the difference in the manager's bonus. So 500 times mu sub x is 1.1, and then 300 times mu sub y is 0.7. We subtract those and we get $340. To get the standard deviation, again, we have to find the variance first. We combine the variances together to get the standard deviation. So I labeled it the variance, so sigma squared sub b. Again, I'm using sub b for bonus. We need to multiply the original standard deviation times 500, and then we can square that so we can add the two variances together. The original standard deviation of the number of cars leased times 300, and then we can square that. So we're doing a transformation basically here. We're transforming like we did in the previous part, the first part of this section, 6.2, where if we're multiplying each of these outcomes by, for this one it's 500, and for this one it's 300, then this is how we get the new mean and the new standard deviation. We could just multiply the original mean and standard deviation by those values. So then we square them because we need to combine the variances together. And for that we get this big number, and then we still want to take the square root because we don't want the variance, we want the standard deviation, which is the square root of the variance. So we got $509.09. All right, we're going to try one last problem. Suppose the height, which we're calling m, of male speed daters follows a normal distribution with a mean of 68.5 inches and a standard deviation of 4 inches, and the height f of female speed daters follows a normal distribution with a mean of 64 inches and a standard deviation of 3 inches. What's the probability the randomly selected male speed dater is taller than the randomly selected female speed dater he is paired with? Okay, so let's talk about what we're trying to find. We want to find that the male speed dater is taller. So that means if we subtracted the two, we want to think of that the male is taller than the female in terms of, we know we're working with like sums or differences. So if we subtract the male and the female, and the male is taller, then that means when we subtract the two, we want to figure out the probability that we get a number that's greater than 0. So we need to find the combined distribution of males minus females, and we want to find the mean and standard deviation of those because then we're going to work with a normal distribution so that we can know the mean and standard deviation of the combined distribution. So the mean of the combined distribution of males minus females is we can just subtract males minus the mean of the females. So what we're saying is on average the difference between males and females, the difference in heights, if we chose a randomly selected male and a randomly selected female, on average the difference in their heights would be 4.5 inches. For standard deviations, we're going to combine the variances together. So we add the variance for the males, which is standard deviation squared. It said the males had a standard deviation of 4 inches. The females had a standard deviation of 3 inches. So we square those, combine them together, we get 25. But we want the standard deviation, so then we need to take the square root of that, which is 5. Okay, let's draw a picture of what we're trying to find. So we want the probability that males minus females is a number greater than 0. We have the mean, we're working with a normal distribution, and the mean is 4.5. We're finding greater than 0. So 0 is down here. I shaded in what we're trying to find, this area that's greater than 0. So we pick a randomly selected male and female, and the male is taller than the female. We're looking for this area. We need a z-score, so we do the value minus the mean over the standard deviation. So the z-score right here is negative 0.9. And then we want the area above that z-score. So we can go to normal CDF and put in negative 0.9 as the lower bound and just a big number as the upper bound. And we get about 0.816. So there's about an 82% chance that a randomly selected male speed dater is taller than the randomly selected female speed dater he is paired with.